Okay, good afternoon, ladies and gentlemen. So our objective for today is that students will be able to create a table, equation, and graph to model an exponential relationship that is decreasing. All right. So if you remember back at the beginning of this unit, we were going over that scenario where we said that Penelope was cutting paper to make ballots for her, I think it was a school election, right? So we said she started off with one piece of paper, she cut it in half down the middle, then she stacked those two pieces of paper on top of each other, cut it in half again, right? She then stacked those four pieces of paper on top of each other, cut it in half again, and we started counting up how many ballots she had after each cut, right? So if you remember, we saw a table where we had first one piece of paper, then we had two pieces after we cut it, then four pieces, and we found out that the amount of paper was doubling each time, right? And that was our first example of exponential growth. So we're looking at an example today. We're revisiting that, except now instead of thinking about how many pieces of paper we have, we're thinking about each individual ballot that is cut. What is the area of each of those ballots? Okay, so remember, we start off with one piece of paper, and for the scenario today, we're saying that suppose that piece of paper is an 8-inch by 8-inch square piece of paper. All right, so if you have an 8-inch by 8-inch square piece of paper, the first question is, what is the starting area of your paper ballot going to be, right? Just that one piece of paper. Now, this document that you can click on here is a tool that's just going to help you to visualize the first couple of cuts, right? Now, when you're stacking paper and you're cutting it, each ballot is always going to look identical. So in this document here, all I have is a picture of one ballot from each cut, right? So the first one here is the initial piece of paper that we have at 0 cuts. It is 8 inches by 8 inches, and I can see 1, 2, 3, 4, 5, 6, 7, 8 by 8. So 8 inches by 8 inches. I want to figure out what is the area of this square, right? You're going to write that answer here, and then also that's your initial value. So at 0 cuts, before you start cutting, the area of that ballot is blank. Type that in here. Then you go back to this document, you scroll down. You're going to see the next one. This is after 1 cut. So the idea is we take this piece of paper, you cut it in half down this line here. Now you have 2 pieces of paper. You have a piece of paper here, you have a piece of paper here. But again, I'm only worried about one of those pieces of paper. So this is one section. It's 8 inches this way by 4 inches this way. So what is the area of this ballot now at 1 cut? And again, just remember, I'm counting up for area. How many square boxes do you have here? That's one way that you can find the area. So that goes here under 1 cut. Then you do the same thing for 2 cuts. This is what it looks like. 3 cuts looks like this. 4 cuts and so on, right? Every time you cut this piece of paper, you're cutting it in half and they're gonna get smaller and smaller. So after you have those, I gave you pictures of the first 4 cuts, you should start to notice a pattern that's going to help you to finish out the rest of this table here, right? Without needing to look, right? Just figure out how are the numbers changing as you move down this table and continue that pattern. Then you're going to start to answer the questions on the next page to help you build an equation. First question though, is looking at that table that you saw, does it look like exponential growth that we have seen so far? And explain why you think that, why you think it does, why you think it doesn't. Next, what is the initial value? We already identified that. Then I'm going to ask you, what are you constantly multiplying by to move down the table? Now, we would call that the growth factor, but it's actually something a little bit different right now because this scenario does look a little different, but you're going to find it the same exact way we found it before. Remember, when we found the growth factor in the past, the way that we did that was by looking at the value at one y value divided by the one directly above it. Right? You're going to do the same exact thing to find the growth factor here, right? Write that down there, and then you're going to build your equation the same way we have been building them. If you're not sure how to do this step, please make sure you come to the Zoom session so I can help you, right? I've given you a lot of examples. Look at the worksheet from last week on Friday, where I actually gave you one of the examples, I believe, for Penelope's fund, right? Same thing over here, right? What you're going to do next is use your equation to answer the following questions here. So the idea is that I'm giving you a number of cuts. Your equation should be able to tell you what the area of each of those ballots is going to be, right? fill those questions out there. Number 8 here is just a small bonus. Sorry, also one thing to clarify for number 7, that's for whatever calculator you are using. So if you're using like a calculator on a MacBook, if you're using one on your phone, you're using a scientific calculator, scientific notation, that's when you see something weird in the calculator. Depending on what you have, you might see E and some numbers afterwards. You might see times 10 to a power, that's scientific notation. So based on the calculator that you are using, it may vary from person to person. After how many cuts do you see that scientific notation, right? That's just what I want you to write there. So you can practice identifying scientific notation. Then last part is making a graph, right? So again, you click on this tool here and the video of how to go about using this tool is online, right? It's on our Google Classroom. I'll try to move it up to the top of the course page to make it easier for you to find. Just don't forget, please come to the Google Classroom if you're not sure how to use this tool. Also, right, try your best to copy and paste the image directly into your document. That works a lot easier than emailing it to me. If you're having trouble copying and pasting it in, come to the Zoom session and you can share your screen with me. I can help walk you through the process. It's not that difficult. Then you're going to answer question number 2, and that's it for the task. The extension is related to what we did today. That's on the last page here, all right? Again, if you have any questions, please make sure you come to that Zoom session. Good luck, and I will see you there.